In this video, you'll see the second set of our 4 core practices. We use these routines at the beginning of every unit. The first practice in this set is getting students to share what they know about an interesting science phenomenon or event. We refer to this as eliciting ideas, but this kind of discourse also activates a lot of prior knowledge so that students can understand which of their past experiences might be relevant to upcoming lessons. The second practice is selecting which of the students' ideas, past experiences, or puzzlements to make part of a public record. And finally, after the lesson is over, the teacher does a quick assessment of how the students talked about the anchoring event and uses that information to adapt further instruction.
Well, for this phenomenon, it's really complex, and so I didn't want them to get overwhelmed or stuck by trying to explain everything, and so I started by simplifying it and picking only one part to begin our initial elicitation of ideas. And so I asked them to explain just why the hare population would change over one cycle. And so during that, I wanted them to have some time to think privately about their own initial ideas, and then also then have a chance to share those with their group, and then as a group come up with a model hypothesis that they could agree on, so kind of a consensus as a group about why that population would change over time.
So you simplified the model so that it was more accessible to all kids rather than presenting kids with all of the complexity and risking having some students just say, that is beyond me.
Right.
Yeah.
And I gave them some information about the hair also so that they could know a little bit more about it before they made a hypothesis. I wanted it to be based on something, not just a random idea out of their head.
And the entry question is this: if you had a population of 50,000 hares, if you don't know what a hare looks like, it's kind of like a rabbit. It looks like this. We'll talk more about that in a second. But let's say you start with 50,000 of them. What do you think would happen to that population? So let's say we start right here, times 0, we have 50,000. What do you think is going to happen after 1 year, and after 5 years, and after 10 years? How many would you have? And go ahead and explain your thinking for that, please. I'm going to ask some of you to come write your ideas or draw your graph on the board so we can think about what our ideas are.
At this point, we are just 2 minutes into the class, but there are already several aspects of Bethany's eliciting practice to pay attention to. She has selected just a part of the more complex phenomenon for students to hypothesize about. Bethany can have her students create public representations of how they're thinking about this problem. These representations can be compared and contrasted with one another. Bethany is not looking for right answers. There aren't any. She wants to hear how students reason about these ideas and what background knowledge they are activating.
Sure. Anthony wants to record his question on the board. If anybody else wants to record their question, you can do that. Yeah, and I want each of these people who drew this graph or somebody who had one similar to kind of tell us what they were thinking. So let's start with the middle. So that's, Kelly, can you tell us what you're thinking?
So what I thought was, like, the hares would die and then reproduce. So I guess it would kind of go up and down.
I said that it's going to increase by kind of like a linear pattern, like about 1,000 every year, because they die, but they reproduce quickly. So.
Okay, so this one is they die but reproduce quickly. These little kind of changes are due to the environment. Okay, so I'm going to add that here. Environment could affect it. This one. Okay.
They would die or grow old, or like the predators will hunt them, but they will reproduce quickly.
So how is it different than this one?
Not really.
Okay. So these are just kind of similar ideas. They just drew it a little bit differently. Although I did hear Jen say something about a predator, which I didn't hear Anthony say. Was that part of your thinking?
Yeah.
Okay, so Jen is similar to Anthony, except for she's adding plus a predator. Okay, and then this one.
So I said that the population will increase and stay the same, but then some decrease. So yeah,
Because
because people, like animals, eat hairs, and so the population will grow, then stay the same for a while, then decrease because they overdo it sometimes.
You should give us more details on how
Yeah.
like the environment, like people humans will affect like the population of the hens.
okay, yeah, I'm gonna give you that information. I'm so glad. So Alan says he wants to know. Anthony said lifespan of the hair. Alan said what?
You should
More
give us more
detail.
details.
I know, but which info did you want?
Like the environment that they're living in, the predators, and like this,
He wants to know the environment. He wants to know the predator,
also the weather or something.
the weather.
And I want to know how fast they can reproduce.
Sure. Okay. So what's interesting about Juan's graph here is I don't know if you can see it where you are, but it goes up, and then it kind of has like a flat part, and then it goes down, and then it goes up, flat, down. And so he's saying the flat part is it can stay the same for a little bit until what? Until they start dying. So this is like can stay the same until, and he said until it's overdone, until they overdo it. Is that you, Wes? Okay. What were you thinking?
I disagree with it.
Okay, can you explain what you originally thought and then why you changed your mind?
I thought that they would like mostly die off because like other animals would kill them and they would die of old age and all that.
Okay.
But then I figured out about reproducing.
Okay, so you originally thought they're just gonna die off from old age. Some other people thought that too, so that we would just kind of see a gradual decline in the population. And then, but now you changed your mind because you thought about reproducing. So what would your graph look like now?
The middle one.
The middle one. So now he thinks this one. All right, and then let's go to this one right here, the bottom one.
I said that they would like rapidly decrease because of like hunting and poaching and stuff.
Okay.
Then they would increase because they'll probably be in danger and reproduce more.
So they somehow get on the endangered species list here, and so then they're allowed to, they have the ability to reproduce.
Yeah.
Okay.
So that would affect it.
Okay, so we have lots of ideas about this, and I guess I'd like to give you a chance to ask any other questions. What are you dying to know? Yeah, Cecilia.
Are there hairs from other areas?
Okay, are there hairs from the area that come to that area? Yeah, I think.
How fast do they reproduce?
How fast do they reproduce? I guess I would like you to also say, I'm going to go back to Cecilia. Why would you want to know that?
Because like it's just like how in America there's been different nations that come and increase the population, and people that leave decrease the population.
She said, are there hairs who come to the area?
More different than
I'll get introduced to the Korean language.
Mm-hmm. And so she's saying she's thinking about America. People come in, the population increases, but people can also leave, so the population could decrease because for that reason. And we're going to see what the data shows, and we're going to start by just observing the data. And here's our graph. What? Yes, Abbas?
Do they only live in snow?
They live, you're going to look today at where they live, but they live places that have snow in the winter, but it's not snow year round. Okay, so what we're going to talk about is just, we're going to tell the story of this graph here. So we're going to take it segment by segment. We're going to start just by looking at what the graph shows you in this first segment right here, from here to here. So A, you're going to tell B, what do you see in that graph? We're not coming up with reasons right now. We're just going to describe what we see. And in your notes, write segment 1 and what you see. But first, A, just tell B what you see. Go.
Full 2 years, which is constant.
Okay, so we have kind of a flat line for 2 years. It's constant. have something to add to that?
Oh, well, he said for every life there's death.
Okay, so can you say a little bit more about that? What do you mean?
Because he means when rabbits might die, then more reproduce.
Okay, so it looks like if we have a flat line here, maybe it means that for every life there's a death.
No, other way around.
Okay, for every death there's life. Okay, so we're gonna go ahead now and move to segment 2, which is from here to here. And B, you're gonna tell A what you see. B, you're gonna agree or disagree, tell them why, and then you'll write it in your notes. B volunteer? Sorry, A volunteer?
My partner said that it increases, then it slowly increases when it gets to the top.
Okay, so you see that it's increasing here and then it's increasing slower right there. Okay. Does anybody have something they want to add to that? Yes?
I think it's some kind of reproducing them or fear.
Okay.
They just spend the time reproducing.
Okay, so he's starting to give us ideas about why he thinks that, but what is your connection to like what the graph means then? What does the graph mean right here? Because here you said you think it means there's a death for every birth.
Yeah.
And what do you think this is then? How do deaths and births compare here?
Every death is 5 lives.
Okay, so there's more lives than deaths here.
Yeah.
Okay. All right. So now it's A's turn again, or if your group had 2 A's, it's the other A. You're gonna say, "What do you see from here to here?" Okay. So this is showing dying, but let's describe what we see on the graph. What's the graph showing? Michelle?
It doesn't go like straight down, kind of curves at the end.
Okay.
So I think it just decreases again.
So it's decreasing. And then Alan and Cesar were talking about that being about death. So we'll go back to Abbas then, and so Abbas is our interpreter here. How does that match with your idea from these two left?
Well, my partner said for every ratio, or for, I don't know, just ratio, the ratio of death is higher than life.
Okay. So we have a high death ratio here.
Yeah.
Is that what you're saying? Okay, excellent. So now in your notes, I want you to tell the whole story of this graph. If you could tell me the story of what this graph shows you, what is it saying? You can talk with your partner about it and record it in your notes. All right, so what we're going to do now is you get to start thinking about why, okay? So there's 2 information cards you'll get to read. Here, let me put this up. We'll talk about your groups in a second. There's an information card about the hairs, and there's information on the back, and then there's information about where they live, and some information on the back. Okay. So you're going to get with your group, and you're going to assign your roles. Remember your green and orange roles. Then read your info cards, 1 and 2. Share your ideas about why the snowshoe hare population follows this pattern. And then as a group, agree on one hypothesis that you agree on. And you'll be making a poster to show that. You'll put a graph on here and explain on the graph what's happening, and then do a description down here of what you think is happening. So remember, once you pick your orange job, I'm going to be listening for these orange sentences, these orange questions. Yeah.
I think I saw one of these.
There are some rabbits that live around here, but I don't know if I...
Well, it has big legs.
Interesting.
Random tennis bleachers.
Well, it says that they live, possible? Like the killing predator. Might be people like this, I would say that you're already thinking about ideas or just still kind of researching? Okay, so here's a graph that might be able to help you show parts that you're thinking about, and you'll end up, once you come up with the ideas that you can all agree on, you'll put them on the graph here. And I want you to try to think of like some ideas that could tell the whole story. So sometimes you might have an idea that only explains this part, and then a different idea for this one, and then a different idea for this one. But I want you to think about if you can get an idea that works for the whole thing. Okay?
like a cause or effect relationship here.
Figure out why the hair population follows this pattern.
A great cause and effect would be their major increase in breeding would lead to too many of the calves out in the street. Start dying off. And once they got experience with some food, started to eat them out.
Okay.
So that's what
Why would the food have started to give out? Okay, so food is an important part here, and then what about this part here where they just were reproducing more? Could that connect to food? Does that connect? Is like food the idea that you're going to think about for the whole graph, or is there two parts to it?
So maybe right here it had a well-balanced amount of food, but then there was an increase in food, so basically increase in hair. Then the food started to grow, and then it would
Since you have a little bit more time, we can maybe start discussing what questions do you now have that can help you figure out if your hypothesis works, and what might you have to know more to see if you're right. If you're done actually, why don't we go to the show So I was going to have you describe your hypothesis now, like now that your group really has cemented it down. Why do you think it happens this way? How is your hypothesis similar or different than the other groups? So on Friday we're going to have a chance to see all the different groups, and what's so interesting is every single group had a different, every single group had a different hypothesis.
Yeah, man.
Some of them had a lot in common, but they had a different